Just let a to the 1 over n be an nth root of a, and let m be a positive integer, such that a to the m over n is equal to a to the 1 over n to the m is equal to the nth root of a to the m. Hopefully this looks familiar, because we actually did this yesterday on a good number of the problems. Yes, we simplified it down, took the radix. Bless you. Now, if the exponent is negative, all we're going to do is put it in the bottom of the fraction and do the exact same thing. That's the only real difference between these two. Now, if we look at an actual example, because sometimes it's easier to look at the problem than it is to just look at straight variables, so 16 to the 3/2. Well, according to our property, we can simplify this or rewrite it as 16 to the 1/2 to the 3rd. Because when it is simplifiable, it's sometimes easier to simplify the radical part, or square root part in this case, than it is to cube it and try to go from there. So if we turn this into a radical, we have 16 inside. Now our index, the number in the little v, would be 2. And since it's understood to be 2, we don't necessarily have to write it. We can if we want, but we don't have to. Now the question is, what's the square root of 16? 4. Because we're looking for what times itself is 16, and that is 4. Well, now we're going to cube 4, multiply 4 by itself 3 times, and get, actually not going to get 4, we would get 64. Because 4 times 4 is 16. Then we're going to multiply 16 by 4 and get 34. Excuse me.
Wait, 16 times 4 is 34.
Or 64. Yeah, 16 times 4 would be 64, not 34. Questions on A? Let's look at B. 32 to the negative 3/5. Well, the first thing we need to do is simplify or get that exponent to be positive. So to make the exponent positive, we move it from the numerator to the denominator, from the top of the fraction to the bottom, giving us 1 over 32 to the 3/5. And now we're going to do the exact same steps as what we did on the previous one. Because we can turn 32 to the 3/5 into 32 to the 1/5 to the 3rd. Now 32 to the 1/5. Really what we're saying is we want to find the 5th root of 32. And once we get that value, we're going to put it to the 3rd power. Now the question is, what is the 5th root of 32? 2. Because 2 times itself 5 times is indeed 32. Now we need to cube 2 multiplied by itself 3 times, which is 8. So 32 to the negative 3/5 is 1/8. 1/8. Questions on this here? We good with this here so far? Well, the first one we started out with for this here was 16 to the 3/2. And we found it is indeed 64. 32 to the negative 3/5 was 1/8. Nothing.
Oh.
Now, some of these questions do show up on the ACT. I've seen them before, and especially B. And the answer choice they want is that right there. They're going to stop you halfway through. Because again, we don't want to get to the final answer. That's what we want to have, and that's where we're going to stop. Does that make sense? So that's where they would want on the ACT. They don't want this here. They give you this as one of the answer choices, and that is the correct answer. It's kind of their way of preventing you from just plugging it in and picking that as the answer. However, there's nothing that says that I can't convert every answer choice they give me into a number and see which one matches. But part of the reason we're doing this here is to kind of help you see how the process works. Because if for some reason you type it in and it gives you just a decimal, means the top or bottom's too big, we can break it down. Because here, 64 to the 4/3, really we're looking at 64 to the 1/3 to the 4th. If 64 to the 1/3, we're looking for what times itself 3 times is 64. That's 1/3. And 64 to the 1/3 would be 4. 4 to the 4th is 256. Your answer is 256. And for the most part, you won't have any real issues with 64 to the 4/3, these numbers where we don't have a fraction. However, the next one, 16 to the negative 5/4, well, the first thing we would do is move the 16 from the numerator to the denominator. Some of these you might have issues with because it might be too big on the denominator, or it just doesn't work out nicely. But we can break it apart. We'd have 16 to the 1/4 to the 5th. Well, our 16 to the 1/4, we're looking for the 4th root of 16, or what times itself 4 times is 16, and that is 2. 2 to the 5th is 32. So 16 to the negative 5/4 is 1 over 32. Questions on this here? Are you ready for the next one? All right, Taylor, 9 to the 1/5, go. You think so? What did it say? $1.55. All right. Well, let's look at the instructions. Evaluate each expression using a calculator. Round your answer to 2 decimal places. So 1.55. That's it. Because here, 9 to the 1/5, we're looking for what number times itself 5 times is 9. Well, there's not one. So we get 1.55. 12 to the 38. 12 to the 3/8, not 38. To the 3/8. We can just type this in. 2.539 or 2.54. That's it. C, the fourth root of 7 to the third. And with ones like these here, we can type them in exactly as we see it. The fourth root of 7 to the third is 4.303, which is 4.30. Yes, because I'm not necessarily going to count off, but we add the 0 to show we rounded. Because if you put 4.3, they're going to assume you round to the first decimal place, not the second. Because whenever we round up, we put a 0 in that spot that rounded up. Because, well, not so much if this was a 5, it would round up to 1. But since this was, I think it was a 3, it rounded down, so that spot is still there. It's just 0. And that's dealing with significant figures. But questions on these here? I don't think we need to see 3 more of how to type it in a calculator. Last thing we're doing today, solving using nth roots. Really, this is the square root method part 2, but with this here, we have 3 main steps. Because whenever we have an equation where the variable only shows up once, we can use this here. Now, our first step is to get the term to the power by itself. We want to get the term to the power by itself. And this equation here, what's our term to the power? Because the term to the power, well, is the x to the 5th, yes? We need to get it by itself. So what's with it? So we would divide both sides by 4. Telling us that x to the 5th is because we want to get that term to the power by itself. Technically, 4x to the 5th is a single term, but we're really looking at that x to the 5th. We're trying to solve for it. So we want to get it by itself. Second step, take the nth root of both sides. We'll take the nth root of both sides. So in this case, what would our nth root be? 5. We're taking the 5th root. And we take the 5th root because the 5th root of x to the 5th is x. 5th root of 32 is 2. Now, since we're taking a 5th root, an odd root, we only have one real solution, yes? I need to mention this to the other hours, but really, for this here, we're only looking for the real solutions, yes? We covered this in higher degree polynomial functions, but the number of solutions is equal to the degree of the function, yes? This is a degree 5, so how many solutions should this have? 5. 4 of them are going to be imaginary or complex. One of them is real. But we're not going to focus on the imaginary because it didn't ask for them. Also, we need trigonometric equations to find. But we have this here, yes? We ready for step number 3? Solve for x. Here, x is already by itself. We have solved for it, so we are done. Really, we could say solve for the variable, because it's not always going to be x. It could be any other letter, but really, we're solving for that x. We're solving for that variable. Are we good with this here? Yes? All right. Let's look at the next one. So we have x minus 3 to the fourth is equal to 21. So this looks different than the previous one, yes?
Yeah.
Okay, what was our first step? First step was get the term to the power by itself, yes? What's our term, in this case, to the power? X minus 3. The whole thing is to the power, yes? We need to get it by itself. Well, it's already by itself, isn't it? Because the x minus 3 to the fourth, that is the term to the power. Is it by itself? Yeah, it's by itself, isn't it? There's nothing being multiplied by it. There's nothing added to it. It is by itself. So step 1 is done. Step 2, put both sides to the nth power, or nth root, sorry. What root would we take? 4. Because the fourth root of x minus 3 to the fourth, those would cancel, telling us we have x minus 3. Now we need to figure out what the fourth root of 21 is. So we have a decimal. Now just like with logarithms, we're going to leave it as fourth root of 21. Because on the homework there is a section asking you to simplify using a calculator round to 2 places. Simplify round to 2 places. With solving, again, we're going to leave it in radical form. No reason to put it in decimal if we don't have to. And we're done, yes? No. It's all for x. So we would add 3. But there is something we're missing. Plus or minus, because again, what root did we take? We took the fourth root of a positive number, yes? Fourth root of a positive number, there are 2 real solutions. So we have to put the plus or minus. Now what that tells us is x, after adding, is equal to 3 plus or minus the fourth root of 21. Anytime we take an even root of a positive number, we add the plus or minus. Because here, there's 4 solutions. Turns out 2 of them are real, 2 of them are complex. We have more. But questions on this here before we look at the next one? You ready for the next one? Find the real solutions of 5x cubed equals 320. Is our term to a power by itself? So we're going to divide by 5. 5x cubed divided by 5 is x cubed is equal to 64. Now our term to a power is by itself, so we can take the nth root of both sides. And our root that we're taking is the third. Now the cubed root of x to the third is x is equal to 4. Now since this is an odd root, we only have 1 real root. And x is already solved for, so we are done. X is 4. Questions on this here? I mean, if we wanted to, we could check this and say 5 times 4 to the third is 320. We ready for the next one? Find the real solutions of x plus 3 to the fourth equals 24. Is our term to the power by itself? So we can take both sides to the what root? To the fourth root. Because our fourth root of x plus 3 to the fourth is x plus 3.
Oh, we did it?
Minus instead of plus, and 24 instead of 21. So can we take the fourth root of 21 nice, or 24 nicely? No. So we can leave it as the fourth root of 24. We can take the cubed root of it, but we can't take the fourth root. It would be 2 cubed roots of 3. But questions on this so far? Now we took an even root of a positive number, so we need the plus or minus. Anytime we take an even root of both sides, we've got to add that plus or minus. Because we did it with the square root method, we had the plus or minus. Same thing with the fourth root. Solve for x. So x is equal to -3 plus or minus the fourth root of 24. Bless you. Questions on this here? How do we feel about these here? Good? Do we need to see another one? No. I'm going to do one more just because I want to show you something with 15. X plus 5 to the fourth equals 16, yeah? Is our term to the power by itself?
Yes.
So we would do what? Take the nth root of both sides, and our nth root is the fourth root, yes? Nth root is any root. Square root, the value is 2. Because when I say the nth root, it could be the square root, cubed root, fourth root, any root I want. I just haven't put in a value for it. So our fourth root of x plus 5 to the fourth is x plus 5. Well, we can go on and give it a try. What's the fourth root of 16? 2. I think it might have been 4 square root of 16. Yeah, you're good. That is very easy to do. So you're good. As we took an even root, we need the plus or minus. So when we took the fourth root of both sides, we got plus 8, x plus 5 equals plus or minus 2. Solve for x. We would?
Minus 5.
Minus 5. Telling us x is equal to?
-5 plus or minus 2.
Well, this time we don't have a radical, yes? Can I add these two together? -5 plus 2.
No, because you don't know which one. You can do it twice.
Because this is really saying what? -5 plus 2? And we have -5.
Minus 2.
Because -5 plus 2 is?
-3.
And -5 minus 2 is?
-7.
Because when we said we took the fourth root of both sides, we have two solutions. It works out that it's -3 and 7. Because we could say -3 plus 5 to the fourth power, and we get 16. And -7 plus 5 to the fourth power is also 16. So both of them work. Questions on this here? You have the rest of the time to work on this assignment.